Hello everyone. I started a series of battery manufacturing learning video sessions for the peoples who want to learn about cell manufacturing and build their career in the battery field. As we've seen, the current market is shifting towards the battery or e-mobility, and the market has a huge gap of professional peoples in this field. I assure you, after completion of the video or the video series that I am going to provide you, you will be able to present yourself as a battery manufacturing engineer or a battery manufacturing associate engineer or a kind of a technician as well in the battery field, and also show enough knowledge to enter into this field. So these sessions are for the beginners as well as for the people who already worked in this industry as well, because here I unfold some of the hidden points in each process which is important from scientific perspective. So without wasting any further moment, let's get started. So I wanted to introduce myself first of all. So myself, Karvit Bharadwaj, I am a chemical engineer postgraduated from IIT VHU in Varanasi. So I have over more than 3+ years of experience in lithium-ion cell manufacturing industry. I am professional in battery designing and battery simulation through MATLAB and certain other software. So I started my journey from the company ATL, which is a part of CTL, which is a world leading company in lithium-ion cell manufacturing. Then lately I worked in Goti, and currently I worked in Tata Battery Division. Let me introduce you about this course and what we are going to learn through all these video sessions. So this is a kind of comprehensive guide which tells us about the lithium ion cell manufacturing process and what are the cons and pros in each process. So I'm going to unfold each and every bit for you guys. Here we learn about the cell manufacturing, let's say material to a final testing level or final quality check. So first of all we understand like what is the lithium ion batteries. So basically the lithium ion batteries are the rechargeable one. There are two types of cells. One is secondary cells and one is primary cells. So primary cells are non-rechargeable, whereas secondary cells is rechargeable cells. So lithium ion cells are comes under second category, which are the rechargeable cells, and it's a kind of energy storage device which we currently use in the electric vehicle. As we seen currently in the market, there are a lot of electric vehicle which is coming, and these are run on the lithium ion cell itself. There are other technologies as well like hydrogen, but currently electric vehicle is booming in the market, and we are going to dive into it. What are the compositions in the lithium ion cell basically? So it consists of the positive electrode, a negative electrode, and a electrolyte as well as the separator. So positive electrode mostly known as cathode for the reference in lithium ion cell, as well as negative electrode is a kind of anode. Another one is a electrolyte, it through which our ions is flow, and that we understand in a little while how the circuit is working. And the last thing is the housing or the case in which my whole system is enclosed. So there are generally four types of lithium ion cells or the formats. So one is the cylindrical cell. It's a kind of cell that we seen regularly. These cells we used in remote or watch, hanging watch or wall watch. So these kind of cells are used, and it's a commonly used one, a cylindrical format. Another one is a prismatic cell. These cells we use in the laptops sometimes previously, as well as some other electronic devices. Pouch cells we are commonly use in our mobile phones as well as laptops nowadays, and the button cells we use in our wristwatch and some electronic toys as well. So these are some general formats that we use for the lithium ion batteries. So let's understand the working principle of lithium ion batteries. So during a discharge or charge, what is happening, what are the reaction is going to be, as I told you, like this is a chargeable battery. So let's understand like what is happening during charge and during discharge. During charge, a lithium ion is travel from a lithium metal oxide to a anode side. So I'll show you what is the reaction happening inside this process, like during charge and during discharge. So let's say this is my charging reaction. So my lithium metal oxide, or let's say lithium cobalt oxide, is split into one lithium ion and one electron. So electron has to be travel through an external circuit, whereas the lithium ion will travel through the separator and reaches towards the anode direction. So this is my anode layer, a graphite layers in which my lithium ion will take place, and it makes LiC6. So you can see here like LiCO2 is split into this, and this Li plus and electron coupled with C6 make LiC6 compound. So this is during charging. While discharging, the reversible will happen where my LiC6 is splitted first in Li plus and electron minus plus C6 and converted into LiCO2 plus Li plus electron, which will be my lithium cobalt oxide again. So this is a kind of reversible reaction. So one thing I wanted to tell you here, like charging is a non-spontaneous reaction, whereas discharging is a spontaneous reaction. So we don't need anything to put, only just a circuit. We have to apply a wire or certain kind of bulb or anything, or if you don't want it to put bulb as well, just a wire connection, and the reaction will start automatically. So it's a spontaneous reaction during discharge. But during charge, we have to pull the charge, or let's say pull the lithium ion from the cathode to anode, or create a potential difference or a barrier through which we force the lithium ion to travel from cathode to anode direction. So this is what is happening during the charging and discharging reaction. One more thing is like during first charge, we have another thing that is comes into picture, which is a kind of SEI layer that is formed during the first charge. So I'll tell you what is SEI layer, and after this process we'll directly jump to the manufacturing process. So this interfaces help us to travel the lithium ion through it, but stop, or let's say it is a kind of barrier for the electrolyte conductive material, or let's say additives. It reduces the passage, or it stops the passage of the electrolyte or electrolyte additives, but only allow the lithium ion to pass through it. So the point is why it is helping us. I'll show you with the diagram. So here we talk about SEI layer. So SEI layer is a exhibiting layer that is formed on the anode layer. So as you can see, this is an anode surface where my SEI layer is deposited. So SEI basically is a key component for the battery or a lithium ion battery, and it helps us for the battery safety as well as the cyclability, like how my charging and discharging is happening, and is also help in the rate capacity, or the how much amount of capacity my battery is giving, basically the ampere hour. That's how we rate our battery. And it also help us in the irreversible capacity loss. So basically whatever my charging is going, and during discharge the same amount, or let's say a little bit less amount of lithium ion is coming, so these losses are handled by the SEI layer itself. So it also helps us to reduce the irreversibility loss, and it is a kind of electrically insulating layer, so there is no conduction throughout this layer. And this also prevents the electrolyte decomposition and ensures like the electrochemical reactions will be happened continuously. So I'll show you later on in the video itself like how this SEI layer works and how it is forming basically. So if we are saying like with this SEI layer, how it is forming and why it is crucial. So basically if the SEI layer is not available inside the system, so you can see here, this is the violet one is my lithium ion, and it is covered with the electrolyte additives, and this is traveling from cathode side to anode side through these additives. So if the SEI layer is not here, the additives itself will go inside the layer of the anode, and it destroy the structure of the anode or the graphite, and because of which my battery will be destroyed and it will not work for longer time. So to avoid this situation, this SEI layer is formed, and this only allows the lithium ion to pass through this layer and stop the additives of the electrolyte. So because of this crucial function, SEI is very important, and it has also some of the other features. And strongly like what is the thickness. So thickness is roughly around 1.5 to 584, like some studies are saying. Based on the SOH, the SEI layer thickness will be growing continuously. So it's not like a one time process, the SEI layer is continuously growing, and this is why the battery start decaying over the period of time. So we can see this process like in our phone batteries itself. When we purchase our phone, the battery is charged or run for a longer time, but over the 1 year or 2 year, the span will be shorter because the capacity is reduced, and the capacity reduction because of the irreversible losses of lithium ion inside the battery. So that is why the SEI is important to control this irreversible losses. So let's just see the video, and later on we just directly jump to the battery manufacturing process. So these are the solvent trapping the lithium ion, and it is collaborating with the electron which is coming through the first cycle or during the charging period. So when charging is happening, my electron is coming from the external circuit and lithium ion is coming from the electrolyte. So after the mixture or after this reaction, this kind of layer is forming. So this is a SEI layer which we see in different color because it has a different composition or different components. And you can see this red ion, these are the lithium ion which is traveling through this SEI layer, and once they pass through the SEI layer, only lithium ion components is going out and remaining will be stopped there. So this is what the SEI layer and how it is helping us.